Welcome back to our YouTube channel. So if you're new here, my name is Tifla and I hope you will subscribe to our YouTube channel, and I hope that you enjoy this session with me. So today I just took another 10 to tackle the problems on vertical projectile. So this vertical projectile, I will divide it into 3 sections, which the first session will be talking about the simple calculations, right? And then the second part, so this is the first part, and the second part we'll be talking about the hot air balloons, right? And the third section we'll be talking about graphs on this topic, right? So this is how we are going to divide this section. So as you know that vertical projectile, there's no much of content, it's just a lot of calculations. So I'll stick to a lot of calculations other than just talking. So before wasting much of time, let's just get straight into it. So when we're dealing with vertical projectile, the first thing that we can talk about, we will be talking about objects that are in motion vertically, right? So we'll be talking about objects that are in motion vertically. So in this session, we are going to take everything that is moving up and down as they are in free fall. So we are going to take everything as it is in free fall. Maybe we want to know what is free fall. So free fall describes the motion. So this is, I can say this is the motion of an object under the influence of gravitational force only. So this is the motion of an object under the influence of gravitational force only. So everything that we're going to deal with, it is at the absence of a friction. So we are going to ignore all the effects of friction. We're going to ignore all the effects of friction, right? So that is free fall, the motion of an object under the influence of gravitational force only. So since I said that vertical projectile doesn't have much of content, so it means that this small content that I'm going to give you, please, you have to understand them very well, since you'll be tested on this more like a lot. So if the motion is called free fall, then it means that the object that is moving under free fall now, it is called a projectile. This is now a projectile. Projectile. So what is the projectile? So projectile is now the object that is moving under the influence of gravitational force only. So we said free fall, it is the motion of an object under the influence of gravitational force only. Now projectile, it is the object that is moving under the influence of gravitational force. Just for an example, if I'm having this object here, right? So this object, maybe it was thrown upwards, so it will move upwards and then it will come back, because everything that goes up must come down, right? So if we throw this object up, it means that this object now that we're throwing up, it is the projectile. This is the projectile. The object itself will become the projectile, and this motion that it traveled, this whole motion is free fall. So it's the motion of an object under the influence of gravitational force only, right? So when we're dealing with vertical projectile, the things that we need to understand, right? So since we'll be working with displacement, and displacement is a vector, and also we'll be working with acceleration, it is also a vector, right? It is also a vector. And also we'll be working with so all these three are vectors. So what does that tell you now if you are working with vectors? You know that a vector is a physical quantity that has both magnitude and direction. So it means that you must take direction into a big consideration so that you can get the right answers, right? So most of the times, since we are going to talk about the vertical motion is either up or down, you have to choose the direction that will work for you, and you have to stick to that direction. As throughout this topic, I'll be talking downwards as positive. So I'll take downwards as positive. So it means that everything else that is going downwards will become positive, and everything else that is going upwards will become negative. So you need to choose the direction, and you need to stick to that direction, right? Throughout when you are working with vertical projectile. So this is one of the important things to master. It is the direction. So the other thing that I'll talk about, it is acceleration. So since we'll be talking about the objects that are not having air resistance or air friction, it means that now our acceleration will be the acceleration due to gravity, right? So it will be the gravitational acceleration. Acceleration, which it will be 9.8 meters per square seconds downwards. Remember, this is a vector, so you must have magnitude and direction. So since I said I'm going to be taking downwards as positive, so it means that always I will have to put this as my positive. Like I always say in vectors, that in physics, nothing is actually negative. Negative just tells us the direction of quantities, right? The direction, and that's how we handle physics vectors, right? So something else that is important when we're dealing with vectors, these are simple notes that I will just write here, and then I will explain how you have to tackle everything down when you are dealing with vertical projectile. So now this is a list of some of the stuff I've written down, right? So let's consider this motion of this object from A up to C, D, E, and F there, right? So when everything is thrown up and it is experiencing free fall, so we said free fall is the motion of the object when only gravitational force is acting on it, right? So when it's under free fall, it will mean that the velocity at its maximum height. So when something is thrown up, it will get to this point at the maximum, and it momentarily come to a stop, right? When it starts to change the direction, right? So here it means that your velocity is 0. So at the maximum height, your velocity is 0. So always remember that at maximum height, the velocity is 0. However, the acceleration is not 0. The acceleration will always be 9.8 meters per square second downwards, right? So acceleration is the same throughout. Here acceleration is 9.8, 9.8, 9.8, 9.8, 9.8, 9. Throughout this motion, the velocity is, the acceleration is 9.8, right? So something else you have to know about this is when object is released or when an object is dropped. So released or dropped, when objects are released or dropped, still their velocities or their initial velocities is 0, right? So here I'm kind of like, I don't want to use initial velocity or final velocity for a reason, which I'm going to give you, right? So let's just say when an object is released, its velocity at that instant, it is 0. And also when an object gets to its maximum height, its velocity is 0. So again, velocities are the same. Velocities at same height, up and down, are equal but opposite in direction. How do I mean? Since we know that acceleration is always 9.8. So if the velocity of this ball, for instance, maybe it starts as 20 meters per second, for example, right? So it is going upwards. Since I said I'm going to take downwards, it's positive. So it means that this going upwards, it will be negative 20, right? So when the velocity is at this point going up, and since A and E are at the same height, so this ball, when it is coming back again at that same point, the velocity will be still 20 meters per second, but now it is going downwards. So the velocities at the same height are equal but opposite in direction. What happens? Because like we know that our acceleration is the same. So when something is going up, its velocities is decreasing uniformly, right? So when it is going up, when object is going up, velocity decreases uniformly, right? Because the acceleration is staying the same. So it means that the velocity is decreasing at the same rate. So as well, let's suppose that when it gets to point B, the velocity maybe is 10, but still negative because it is going up, right? So maybe still it is negative 10, right? So when it goes up like that and come back at the same height, can you see that B and D are at the same height above the ground? So it means that the velocity here as well, it is 10, but now going down. So this kind of information, they won't tell you in the question. You just have to know this. So if you have somewhere else to write, please just take notes and write this down, since they'll help you a lot when you're dealing with these questions. I will help you with these questions, but always remember that the velocities at the same height above the ground are always equal, but opposite in direction. So it means that here the velocity is 10, here it is negative 10. So when it goes up again, it is decreasing up until it gets to 0. So the velocity is 0, but the acceleration is never 0. So it will start to go down. So when an object is going up, we said velocity decreases uniformly. When object is going down now, when object is going down, the velocity increases uniformly as well. So the velocity will start to increase uniformly, up until you get to this point. The velocity here and here, they're equal, because it takes the same distance to get to this point and also to get to this point. So again, when it starts to decrease, when it starts to go down again, the velocity is increasing uniformly because it is going down and acceleration is going down. So it means that when it gets to E, the velocity is the same as what we started with, at the same heights. So these are at the same height, and the velocity will eventually start to increase like that up until it gets to the ground. So this is how you have to tackle this. And if they're asking for displacement from this point to this point, You have to understand the questions nicely. So like I said, with height and displacement, right? So height and displacement, they are two different things, right? So when they're asking for the height or the distance, they're asking for this total path that is taken up until to get to that. So let me just say distance actually. So when they're asking for the distance, they're asking for this whole distance that this traveled. So it means that we can calculate the distance from here to here. So we know that the distance from here to here is equal from here to here, right? So it is this distance multiplied by 2, right? And also we can calculate the distance from here to this point, right? So now we are having, we can add all the distances that the ball took, right? But now if they're asking for the displacement, a displacement is a different subject now. Because displacement, they're just asking the distance from point A to point F, the last point. That is the displacement, right? So always remember that distance and displacement, they are not the same thing. So also we can get to time symmetry, right? So also as we said that the velocity is the same at this point and this point. So it also means that the time it took for the ball to get to this point, it will be also equivalent to the time the ball will take from this point to this point. Can you see that? So as long as the distance between 2 points is the same, it means that the time it takes at those 2 points, it is the same. For an example, if it takes 2 seconds to get from A to B, it means that it would also take 2 seconds to move from D to E. So the distance will always be equal at those positions. I mean, the time will always be equal at those distances from here to here and from here to there. So if it takes 5 seconds to get to this point from A to C, if it takes 5 seconds, it means that it will also take 5 seconds to move from C to E, like that. So the distances, the distance from here to here and the distance from there to there, it is the same. So it means that also the time will be the same. So always remember that as well. The time from same points in the path is always the same or equal, right? So before you tackle any of these problems of vertical projectile, I'll advise you to write a list of everything that you are given, because like sometimes they give you like at this instant the velocity is this much and it takes this much time to get to this position. Just write everything down. In addition to that, also write everything that you know or that you can conclude from what you're given. Just like if they say this ball moved from A to C, right? So we know that C is at its maximum height. So you can also conclude that at C, velocity is 0. They won't tell you that, right? So also the situations that you can see that you can conclude, just conclude by writing also that. And on top of that, they won't tell you if they say something is dropped, they won't tell you the velocity. So you have to know that when something is released or dropped, the velocity is 0. So it is your duty to conclude some of the stuff that they don't tell you, and you write them down. You make a list for yourself and then you write them down. So since I said I didn't want to say this is the initial velocity or final velocity, I'll explain this in the next session. So let's take a look at this motion. So this object moved from A to B, B to C, C to D, D to E, then E to F, right? So also when you're given something like this type of motions, that there are a lot of things, just label your situations A, B, C, D, and so on, right? So how does that help you? It helps you in an order that if maybe you are using the calculation from A to C, maybe you are trying to find anything at C or A using this path here. It means that here at A, everything else will be initial, just like the velocity, it will be initial. And when you get to this, then everything there will be the final. So now we'll be talking about the final velocity, right? So I don't really like to explain what is initial velocity and what is final velocity. But in context, I can just say the two positions that you are having, or the two positions that you are interested in, the first one is the initial and the final one will be the final position, right? So also you can be asked to make calculations from maybe C to D. So if you're making calculations from C to D, you also have to know that your C now becomes the initial and now your D becomes your final. So I cannot really say that this is the final, but I can only say that this is the final or the initial depending on the positions that we're dealing with. So from A to C, it was the final, but now from C to D, it is our initial. Now we are starting there and ending there. So it means that D now is our final. And also if we are trying to calculate from D to F, from D to F, if we are trying to calculate anything from D to F, it means that D now is our initial and F now is our final. So just like that, that's how we deal with this vertical projectile. So now I'm just going to write the equations of motion and then we can explain them a bit and you can try to familiarize yourself with these formulas. And in the next chapter, I'm going to focus on calculations. So let's just see how this goes. Like I said, that it is important to label your part of that the object took, right? So A, B, maybe C, like that, maybe D, or maybe C, D. So as I said, it is important to do this. It is also important, I also said it is important to write a list of everything that you are given down. So after writing a list of what you are having down, so now you can decide what are you trying to find. Those are the questions that you should ask yourself and you can be able to think through the solution. So first you ask yourself, what do you have? What do you have from the information that you are given? And also what do you have from things that you concluded, right? What do you have? Those are the questions you have to ask yourself. And the second thing, what am I looking for? What am I looking for? And lastly, the question that you can ask yourself is, which formula can work? Which formula can work? So just a heads up, you also have to know that at some of the times it's not possible to find the answer using only one formula. So you just ask yourself, what do I have and what am I looking for? So you can find the other ingredient that can help you to find the answer being in this formula, and then you can use this formula, and then after that you can use this formula to find your final solution that you are looking for. So that's what you have to always know. And lastly, for you to be able to master this topic, I won't lie, there's no any other medicine, there is nothing else I can do, there's nothing anyone else can do, but it is only yourself that can do something. So the final medicine for this is to practice, practice a lot of questions. I'm telling you, believe me, if you practice a lot of this, they become simple just like that. At first you'll be needing all these formulas when you are calculating, like checking the formulas, But once you practice a lot, you won't need these formulas, because like you'll be knowing them by heart, right? So that's the final message that I can leave you with: practice. So on the next session, I'm going to be dealing with the calculations. I hope you tune in and watch, right? So until then, see you on the next one. So don't forget to subscribe, like, and share.